as I'm sure you already have read, this is solving systems of linear equations in 3 variables. Okay, in order to solve system of linear equations in 3 variables, it would be real helpful to know how to solve them in 2 variables. So you may want to make sure you know how to do that one. So solving in 3 variables, ton of fun. I'm super excited about this here. We get to do a lot of math, get a lot of thinking. Really exciting here. There's a couple of different ways to do it. Looking here, you just kind of got to look at the equations and try to figure out which way is best to solve this system of linear equations. And then once you figure out which way is best, then you start moving right along. There's 2 methods. Linear combinations is one method, which means that you're going to try to cancel out one of them, one of the variables, x, y, or z, or the other method is substitution. I think we're going to cover an example of both. And in this example, I'm looking here. I think, I don't know. I'm looking. I'm thinking maybe we try a little bit of both. We try a little bit of both. You see this third equation, 3y plus z is equal to 17. Well, our whole goal is to try to get down to where we get one variable is equal to a number. X is equal to something, y is equal to something, or z is equal to something. So we have to start eliminating variables somehow. And what I want to do here is I'm looking at this third equation, and I'm going to subtract 3y from both sides, leaving me with z is equal to 17 minus 3y. You may want to make sure that you have some room on your paper to do this. This problem's, and we keep things organized. We need to make sure we keep things organized because we don't want to lose any of our work. Sometimes it just comes up missing and wants to go out for ice cream or coffee or something. I don't know. It just disappears sometimes. So make sure you keep an eye on all of it. Keep things organized and space things out. All right, so we know z is equal to 17 minus 3y. I'm going to take these 2 equations and put that in there for z. So let me do that. I'm going to take 17 minus 3y and plug it in for z. So that means we have 5x plus 2y minus, now what does z equal? 17 minus 3y. And that is all equal to negative 7. And down here in the bottom, x minus 2y plus 2. And now this is z. What's z equal to? 17 minus 3y. That's all equal to 0. What was that? Where did that come from? Okay. Right on. Now we just need to use some algebra skills and simplify those 2 equations. So let's go ahead and simplify those 2 equations. In the top here, let's simplify this. We know that this is going to be negative 17 because this negative sign comes to everything inside. So 5x plus 2y minus 17 and then plus 3y. Combine like terms. 2y and 3y make positive 5y, and let's add 17 to both sides of the equal sign. So 5x plus 5y equals 10. 5x plus 5y equals 10. You notice I'm using different colors here to keep things organized. You may want to either do that or make sure you keep things spaced out. Maybe use some arrows like we've done up here. Now in this second equation, let's look at that. Go ahead and simplify what we can. We have x minus 2y, and then we're going to distribute the 2 to everything inside, giving us 34 and negative 6y. That's all equal to 0. What? Get rid of that 0 so we can stop saying it. Well, subtract 34, and we do not have that anymore. Get out of here. Get out of my way. Oh, there we go. So that makes a negative 34 on the right side. Combine like terms, negative 2y, negative 6y, negative 8y with x. Okie dokie, we have two equations. We still have two equations. Those two. So that's what we have to use. Let me go to a new slide here. Let me go to a new slide. You can probably just maybe move on down on your page. 5x plus 5y is equal to 10. That was negative 34. What was that one? Was it negative 8y? Let me make sure that I have that right. X minus 8y is negative 34. X minus 8y is negative 34. There we go. Now, at the beginning of this video, I told you if you could solve a system of equations in two variables, then you could do the three variables fairly easy. Well, look what we have here. We have a system of equations in two variables. So let's go ahead and solve this out then. Two variables, what do we have to do? I think I'm going to multiply this by negative 5. If I multiply that by negative 5, that leaves negative 5x, positive 40y, and what's positive? 5 times 30 is 150, and 5 times 4 is 20. So there we go. And let's bring that first equation down here. 5x plus 5y is equal to 10, so that way you can see what we're doing here. Now, since the x's are the same, we know that those will cancel each other out when we add these two equations together. And adding these two equations, 40y plus 5y will give us 45y. 170 plus 10 is 180. So in doing this, what are we going to get? Divide both sides by 45. I believe that would be 4. Y is equal to 4. Okie dokie then. We are moving right along. Moving right along. All right, let's take 5x plus 5y equals 10. 5x plus 5y equals 10, or we could have used the bottom equation, x minus 8y equals negative 34, but I'm plugging in, remember, y is equal to 4. So if we have 5x plus 5y, but what's y? Y is 4, and that's equal to 10. Now let's solve this out for x. We're going to subtract 20 from both sides, leaving us x is equal to negative 10. Divide both sides by 5, x is equal to negative 2. There we go. Negative 2 for x, 4 for y. This has 3 variables to it. What is z? Negative 2 for x, 4 for y. What is z? Well, let's go back to what we said here. I thought we said z was equal to 17 minus 3y. Well, what is 17 minus 3 times y is 4? So isn't this 12? 17 minus 12, and 17 minus 12 is 5. So then what do we have for z? 5. Z is going to be 5. So that's one method. We use substitution there to start off to eliminate the variable z, and to only leave us with these variables x and y. So So now we have solved that one. Let's look at this next one here. This next one, this one isn't exactly like the first one we started with. The first one we started with, you notice how there was not an x in this third equation, and that's partially part of the reason why we solved and got z by itself. The other reason was because there was the invisible 1 in front of z, and that just kind of made it nice. But there's 3 variables in every single equation. 3 variables in every single equation. What are we going to do? First off, we're going to take 2 of these equations at a time and kind of put them together and eliminate one of the variables. I'm looking at this one is fairly easy. It doesn't matter which one you want to get rid of. But I'm going to look at, let's say, these 2 equations. I'm going to kind of combine those together. And then I'm going to combine these 2 equations together. So I hope you have this written down. Have this written down. See what I can do here. First equation, x minus 2y minus 3z and second equation, 2x plus y plus z equals 6. There's the first 2 equations. Now, what do I have to do to this top equation in order to cancel out the x's? Well, that's a positive 2. I want to multiply everything by negative 2. Multiply everything by negative 2. Negative 2 times x. Negative 2 times negative 2y. That would be a positive 4y. And negative 2 times negative 3z. That's a positive 6z. Don't forget the negative 1 way out here. Way out here. Negative 2 times negative 1 is a positive 2. So now we have these 2 equations. Let's combine them. X's cancel. If the x's cancel, that now leaves us 1y, 4y, add together to make 5y. 1z, 6z adds together to get 7z, and 6 and 2 make 8. 6 and 2 make 8. Okay, so there's that part of it. So now, let's look at, that was the first 2 equations we looked at. Now let's look at the third equation. Let's look at the third equation combined with the second equation. So what do we have to multiply? Since we got rid of x in the other problem over there, what do we have to, we want to get rid of x's here. What do we have to multiply this by to cancel it with that 2? Once again, it's negative 2 again. So in doing so, we're going to get negative 2x, negative 6y, positive 4z, and we double 13 to get negative 26. Okie dokie. Now let's go ahead and bring this equation down. 2x plus y plus z is equal to 6. Add those together. Cancels. It gives us negative 5y plus 5z, and that's equal to negative 26 plus 6. You got it. Negative 20. And so now we have this equation with 2 variables in it now. X is gone. We have y and z there. In this equation with 2 variables, x is gone, y and z there. So we're ready to go. And didn't we already talk about if you could solve the two variable systems, you were going to do okay with the three variable systems. And this is where we're at. We got real lucky on this one because you notice how the y's are already going to cancel each other out. Sometimes you may have to go ahead and multiply one of those equations or even both of those equations, so that way another variable will cancel itself out. 5y plus negative 5y cancels. 7 plus 5 here is 12, so we have 12z. 8 plus negative 20, negative 12. Oh, that's an easy one. Divide both sides here by the positive 12. That leaves us z is equal to negative 1. Can't beat that. We're going to take this one here. We're going to plug in for z. Plug negative 1 in for z. And that leaves us this. So we have 5y minus 7 is equal to 8. Add 7 to both sides. What is 8 plus 7? That would be 15. Divide both sides by 5. Y is equal to 3. We are super duper close to the answer here. Y is 3. Z is negative 1. Still looking for x. Where's x? Where's x? Okay, so if y is 3, z is negative 1, we come back to the beginning, one of those equations that we had at the very beginning before we canceled x out. And it doesn't matter which equation you're going to use. I'll go ahead and use the one over here by itself. So y was 3. So we're going to plug a 3 in there for y. Z was negative 1. And so that's what we're looking at. And we go ahead and solve it out for x. 2 times negative 3, that's negative 6. Negative 3 and negative 1 make a positive 3. Negative 6 plus 3. Negative 6 plus 3, yes. We're going to add 3 to both sides. Negative 1 plus 3 will give us a 2. Gives us a 2. X is 2, y is 3, z is negative 1. And now you're finished. You have all those variables. You can plug them back into the 3 original equations here and make sure that that it works out. And that'll verify that you've done it correctly. A lot of steps in this one. The most important thing is you don't lose things. You plan on taking plenty of room to solve. All right, one last example here, and I know you're going to love this one. Alrighty, our third example here, which is going to be our final example. It's special case here. And so let's look here. Since we have all 3 variables and all 3 equations, let's go ahead and eliminate some of those variables. And in order to eliminate those, I'm going to, let's eliminate the x variable here. So I want to leave this one as 3x minus 2y plus 4z is equal to 1. And let's go ahead and multiply this equation by 3. That's x, like x multiplication times 3 in case you couldn't figure it out. But if we multiplied it by 3, that would leave us 3x. And we don't want 3x there because the x's wouldn't cancel. So let's multiply by negative 3. There we go. Negative 3x. Negative 3 times 1y is negative 3y. And negative 3 times negative 2z will give us a positive 6z. And negative 3 times positive 3 will give us a negative 9. Let's go ahead and cancel out those x's, leaving us with negative 5y plus 10. Oh, that's not a z. We're going to go plus 10z. And 1 and negative 9 make negative 8. Okay, so we have that part of it. Remember to keep things organized here. Now let's go ahead and take these 2 equations. I'm going to go ahead and put this one right here. 2x minus 3y Positive 6z is equal to 8. I think I said plus 3y. It was actually minus 3y. I wrote it down correctly, though. And here, well, what do we have to do in order to cancel out those x terms? We have to multiply by negative 2. And if we multiply by negative 2, negative 2x, negative 2 times y is negative 2y, negative 2 times negative 2z, so negative negative makes a positive 4z, and negative 2 times 3 will leave us a negative 6. X's cancel out, leaving us with negative 5 plus 10z and a positive 2. So there we go. So now we have our two equations. We're just down to these two equations. Well, let's look there. We notice that we can go ahead and cancel pretty easily if we multiply everything in the bottom equation by negative 1. It makes that positive, makes that 10 negative, and it makes this 8 positive. And so what are we going to get here? Y's cancel. 10z plus negative 10z will leave us with 0z, which is 0. And then what is 2 plus 8, which is 10. Voila! There we go. Absolutely. Well, that's mind-boggling. 0 is equal to 10? No. Can't be. And it's true that it can't be. When you come to a part where you have 0 is equal to 10, or you have some number is equal to another number that it's not equal to, when this statement here, this final statement is false, when that is false, you have an answer that is no solution. Or there's no solution to the intersection of those three equations. Those three equations will not be meeting at any single place. Okay. Like I said, that was a special case. No solution. If you there are times when you get to a point where it'll look like this. You notice there's no variables here, and even in the previous example, there were no variables down here. 0 equals 10, no variables. No variables here. 4 equals 4. This would be infinitely many solutions, and it doesn't matter which number it is. 8 equals 8, negative 12 equals negative 12. Anything like this, when all the variables have canceled each other out, and you're left with that, infinitely many solutions, because this equation is true. Okay, that's all we have for today. We will see you very soon.